Section 8.3 is all about special right triangles. Once again, put this in your notes. Section 8.3, all about special right triangles. There are two special right triangles. One is called the 45-45-90, also called the isosceles right triangle. And the second is the 30-60-90 triangle. Now these are special right triangles because their side lengths fall into certain ratios. Let's first take a look at the 45-45-90 triangle. The 45-45-90 triangle starts with a square. So the origins of this triangle come from asking the question, how long is the diagonal? Well, if, for example, we consider side lengths of 5, using the Pythagorean theorem, we know that the diagonal squared is equal to 5 squared plus 5 squared. And solving for d, we get that d is equal to 5 square roots of 2. Now, if instead of 5, you tried this with, let's say, 6, and ran the same process, you would get that the diagonal is 6 root 2. So notice that the side lengths and the diagonals are related. If instead we had any possible side, let's call it n, then the diagonal is going to be n root 2. So for every 45-45-90 triangle, the side lengths, in other words the two legs and the hypotenuse, will always follow a certain pattern. This is true because each 45-45-90 triangle is similar to every other 45-45-90. So in sum, if the two legs are n, the hypotenuse is n root 2. Now let's look at a couple of examples. Let's say we have this 45-45-90, and one of the legs is 13. The first thing you ought to do is label the two legs n, and the hypotenuse is n root 2. Now, the known side is 13. And since that is the n side, we know that n equals 13. So therefore, the other leg is also equal to 13. And if you substitute the value of 13 in for n, we know the hypotenuse is 13 root 2. Here's a slightly different example. We have an isosceles right triangle. In other words, it's a 45-45-90. And let's say we know the hypotenuse is equal to 4. Well, the hypotenuse is the n root 2 side. And so in order to find the legs, we need to find out what is n. So if n root 2 equals 4, let's solve for n. Divide by root 2 on both sides, and then we need to rationalize the denominator. We do that by multiplying by root 2 over root 2. And so that simplifies to 4 square roots of 2 over 2, which is 2 root 2. And so now we have our value of n, which means that the two legs, which are congruent, the two legs are 2 square roots of 2. Next, let's look at the 30-60-90 triangle. The 30-60-90 has its origins in an equilateral triangle. If you construct an altitude of a if you construct an altitude of an equilateral triangle, then we know, since all the angles in an equilateral are 60, we had a 90-degree angle because it's an altitude, we create something called a 30-60-90. Now in every 30-60-90, the hypotenuse is going to be 2n because the short leg is half of the length of a side. So we have n, 2n, and then that diagonal is going to be n root 3. We can verify that that altitude is n root 3 using the Pythagorean theorem. If we say n squared plus diagonal squared is 2n squared, then solving for d gets us that n is equal to, pardon, the diagonal is equal to n root 3. And so every 30, 60, 90 is going to follow this same pattern. The short leg is n, the long leg is n root 3, and the hypotenuse is 2n. So 3 examples to go with this. In the first example, let's say that the short leg is n, or pardon, the short leg is 10. Well, the short leg is also n, the long leg is n root 3, and the hypotenuse is 2n. So therefore, n equals 10, so we know the hypotenuse is 20, and n root 3, if we sub in the value of 10 for n, we have the long leg is 10 root 3. The second example, what if the hypotenuse is equal to 10? Well, the hypotenuse is the 2n side of that triangle. So we have n, 2n, and n root 3. Since 2n is equal to 10, we know that n is equal to 5. And so therefore, the short leg is 5, the long leg is 5 root 3. And lastly, let's say the long leg is 10, and so that means that the n root 3 side equals 10. And so solving for n, we get that n is equal to 10 over root 3, which we then have to rationalize the denominator. So we have n is equal to 10 root 3 over 3. And so that means the short leg is equal to that length, 10 root 3 over 3. The hypotenuse is twice as big, so we would say 20 root 3 over 3. Next, just a couple of word problems. First one, find the exact length of an altitude of an equilateral triangle with a perimeter of 24 miles. Take a minute and copy this down. Now, we know we're dealing with an equilateral triangle. Next, we know its perimeter is 24 miles. That means each side length is 8. And our job is to find the length of an altitude. By the way, the word exact in this case, whenever you see that word, that's kind of a clue that you might have a square root somewhere in your answer. Not necessarily, but you might have a square root somewhere. And so, if we just look at the 30, 60, 90, we know that the hypotenuse is 8 miles long. Therefore, half of the hypotenuse is 4. And so the altitude length is 4 square roots of 3 miles long. Here we have a chessboard. A chessboard is made up of 64 squares. All, let's say, the side lengths are 1.5 inches long. Find the exact length of the chessboard's diagonal. Well, a chessboard is a square made up of 64 squares. If each of those squares is 1.5 inches in side length, that means in our 8 by 8 grid, the side lengths are 12 inches long. And so then the diagonal creates a 45, 45, 90 triangle. The reason it's 45, 45, 90 is that diagonal creates an isosceles right triangle. So n is 12, and therefore the diagonal is 12 root 2 inches long.